Right, for today, we're going to be using a few formulas. First, let me talk about what we call the double angle formulas. The double angle formulas, I mean, what if I have sine of 2 theta? What if I have cosine of 2 theta? Now, for this one, we're going to have a few choices. Or what else? What if I have tangent of 2 theta? Now, for sine of 2 theta, the formula we're going to use is 2 times sine of theta times cosine of theta. For cosine of 2 theta, I'm going to use either cosine squared of theta. What that means, the square there means is cosine theta all squared, minus sine squared of theta. I can also use 2 times cosine squared of theta minus 1. Or if I want to, I can use 1 minus 2 times sine squared of theta. Now for tangent of 2 theta, I'm going to use 2 times tangent of theta over 1 minus tangent squared of theta. Write down these formulas. We're also going to use what we call the half angle formulas. Half angle formulas. For that one, I'm going to be dealing with sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. My formulas for this case are going to be for sine of theta over 2, plus or minus, depending on the context, the square root of 1 minus cosine of theta over 2. For the half angle of cosine, I'm going to use plus or minus, depending on the context, 1 plus cosine of theta over 2. And for the half angle of tangent, I'm going to use plus or minus the square root of 1 minus cosine of theta over 1 plus cosine of theta. Make sure you know these formulas. They're going to be given in the homework, but make sure you know them in order for us to be able to do our work. Let's take a look at our practice. Question number 31. Cosine of theta is given, and my theta is in between 180 and 270. All right, 180 and 270, that's the third quadrant. So let me create my x, my y axis. I made my third quadrant a little bit bigger because that's where theta is. And I'm just going to say theta is, I'm just going to put it somewhere in there. The reason why, because I need to make a triangle. Here's theta. I always make the 90-degree angle at the x-axis. All right, so I know that cosine is given, and I know cosine is adjacent over hypotenuse. Hypotenuse is always positive. The adjacent is negative radical 31. I don't know the opposite side. I don't know this side. I'm going to call it x. But because of Pythagorean theorem, I can solve for that side. I know that x squared plus the negative radical 31 all squared is equal to 16 squared. So that means that x squared plus 31 is equal to 256. Let me subtract 31. That means that x squared is equal to 225. That means that x must be the square root of 225, which is better known as 15. I know all my three sides. Now, why do I need all three sides? Because from the formulas that I have for cosine of 2 theta, The one that I'm going to use is going to be cosine square theta minus sine square theta. From the formulas that I have, that's the one that I want to use. Cosine of theta, I know is negative radical 31 over 16th all squared minus 15 over 16th all squared. Because I know sine is opposite over hypotenuse. So I have 31 over 256 minus 225 over 256. Now 31 minus 225, that gives me negative, I'm going to put the negative at the front, negative 194 over 256. Simplify for each fraction if possible. In this case, let me divide each number by 2. I'm going to simplify my fraction as negative 97 over 128. The way I'm going to type this will be negative 97 over 128. Take a look at sine of 2 theta. Now here it says theta is in between 0 and 90. So I'm going to make my x and my y-axis, I made quadrant 1 bigger because I'm going to say theta is about here. I need to make a 90-degree angle with the 90-degree angle on the x-axis. Here it says cosine is 5 radical 34 over 34. Remember, cosine is adjacent over hypotenuse, so I was given the adjacent, the hypotenuse. Let me solve for the opposite side. This side, let me call it x. So I have that 5 radical 34 squared plus x squared is equal to 34 squared. Now, the radical, I know 5 squared gives me 25. Radical 34 squared gives me 34. Now 25 times 34 gives me 850. So I have that 850 plus x squared equals 1,156. Let me subtract 850. So I have that x squared is equal to 306. That's not a perfect square, but I have that x is equal to the square root of 306. Thinking, can I simplify the square root of 306? Let's see. I can split this as radical 9 times radical 34. So that means this is 3 radical 34. So I'm going to simplify to 3 radical 34. In previous sections, we learned how to simplify by radical. Okay, for sine of 2 theta, I'm going to use 2. The formula that I have is 2 times sine of theta times cosine of theta. So I have 2. Sine of theta, I know it's opposite over hypotenuse. So 3 radical 34 over 34. Cosine is 5 radical 34 over 34. Now, I'm going to multiply all these out. And see, for the top of my fraction, I'll put over 1. For the top of my fraction, I'm looking at 2 times 3 times 5. Looking at those numbers. 2 times 3 times 5, that is 30. My radical 34 times radical 34, that gives me 34. All right, so on the top of my fraction, I have 30 times 34. Now at the bottom of my fraction, I have 34 times 34. Let me cancel this 34s. So my answer is 30 over 34. Simplify your fraction as 15 over 17. Type it as 15 over 17. Now let's take a look at the double angle of tangent. Tangent is between 90 and 180. So let me draw my x-axis and my y-axis, and I'm emphasizing my second quadrant a little bit bigger because that's where theta is. I'm going to say this is theta. My 90 degrees has to be at the x-axis. I know cosine is given, and I know cosine is adjacent over hypotenuse. The negative, I'm going to give it to the adjacent. My hypotenuse is 13. This other side of my triangle, I don't know it. So I'm going to call this x squared plus negative 12 squared is equal to 13 squared. I have that x squared plus 144 is equal to 169. Let me subtract 144. I get x squared is equal to 25. So x must be the square root of 25. So I'm just going to say this side is 5. Now that I have all three sides of my triangle, now the rule that we know for the tangent of 2 theta is going to be 2 times tangent of theta over 1 minus tangent squared of theta. So I have 2. Tangent of theta, I know tangent is opposite over adjacent. So 5 over negative 12. Now at the bottom, I have 1 minus. I know tangent is 5 over negative 12, but tangent squared, that will be 25 over 144. Remember, tangent was 5 over negative 12. Tangent squared, I squared each of them. Okay. So let's simplify even more. Focusing on the top only, I have 2 over 1 times 5 over negative 12. My 2 and my 12 simplify. If I know how to multiply fractions, I can simplify first. So that gives me negative 5 over 6. Now at the bottom, my 1 at the very beginning, let me write that as 144 over 144. Just so I can have it as a fraction with a common denominator. And that gives me 119 over 144. I know when I have a fraction of two fractions, I have then what I have here is negative 5 over 6 times 144 over 1/19. All right, so let me simplify things out. Let me divide by 6. Let's see, 144 divided by 6 is 24. My answer is negative. 5 times 24 is 120 over 1/19. The way I will type this will be negative 120 over 1/19. All right, so we just practiced the double angle formulas. I did it for cosine, sine, and tangent. Now let's practice the half angles. My theta is in between 0 and 90. So let me draw my x and my y axis. Let me make bigger my first quadrant. I'm going to say theta is here. My 90 degrees is on the x-axis. Have the cosine is 4 over 5. I know cosine is adjacent over hypotenuse. So 4 over 5. Let me solve for this other side. Let me call it x for right now. I have that x squared plus 4 squared is equal to 5 squared. So I have that x squared plus 16 is equal to 25. Let me subtract 16. So I have that x squared is equal to 9. That means that x must be the square root of 9, better known as 3. For sine of theta over 2, I gave you guys the formula plus or minus, depending on the context, of 1 minus cosine of theta over 2. I'll deal with the square root at the end. Let me just deal with the fraction first. So I have 1 minus cosine of theta. I know cosine is adjacent over hypotenuse. So 4 over 5 all over 2. So I'm just dealing with the fraction first. My 1, let me write that as 5 over 5. Because then 5 over 5 minus 4 over 5, that is 1 over 5 over 2. So that is basically 1 over 5 times, I know 2 is 2 over 1, but since I have to do the reciprocal, I get 1 over 2. So that gives me 1 over 10. Remember, a division of two fractions, leave the first fraction alone, times the reciprocal of the fraction at the bottom. So I said that gave me 1 over 10. Now I'm going to do the square root on it. When I do the square root, I'm really going to do the square root on everything. So the square root of 1 is just 1. The square root of 10 is square root of 10. So that's what I have so far. I cannot have radicals at the bottom. So I'm going to say radical 10 times radical 10. So it gives me radical 10 over 10. And that's it. My tangent in the first quadrant is positive. So radical 10 over 10. How do we type this? Radical 10 over 10. Let's take a look at question number 35. My theta is in between the 180 and the 270 degrees. So that means I'm in the third quadrant. Theta is here. My 90-degree angle is on the x-axis. I have the cosine. I know cosine is adjacent over hypotenuse. My adjacent is -4. My hypotenuse is 21. Let me solve for the third side. I don't know the third side for right now. So I'm just going to say x. So I have that x squared plus -4 squared is equal to 21 squared. So I have that x squared plus 16 is equal to 441. Let me subtract 16. So I have that x squared is equal to 425. Not a perfect square. However, I can break this as, I know that x squared is this, x is the square root of 425, but I can break this as 25 times 17. So I'm going to call this 5 radical 17. Okay. Cosine of theta over 2. I gave you guys the formula plus or minus, depending on the context, of 1 plus cosine of theta over 2. Okay. So I'm just going to say I'm going to worry about the fraction first. So I have 1 plus, I know cosine of theta is -4 over 21. And all this is over 2. Let me deal with the fraction on the top. My 1, let me write it as 21 over 21. So that means I have 17 over 21 all over 2 over 1. So I have 17 over 21 times 1 over 2. That means that I have 17 over 42. Now let me deal with the square root. I'm going to square root everything. So that means I have square root of 17 over square root of 42. I'm going to multiply top and bottom by square root of 42. So I have a 42 at the bottom. Now on the top, 17 times 42 is the square root of 714. Cannot simplify for anything else, so that's pretty much it. Now let's take a look at tangent of theta over 2. The formula that I gave you guys. Oh, and one thing here. Let's take a look at our sine. Yeah, that looks good. So radical 714 over 42. All right, now looking at number 36, the formula I gave you guys for tangent of theta over 2, it was plus or minus the square root of 1 minus cosine of theta over 1 plus cosine of theta. I'm in between 0 and 90. One thing that I did on 34 and 35, I didn't have to, but I wanted us to practice, was creating this triangle. I did that in 34 and 35. If you notice, I'll use only cosine. I already had cosine. I can do that triangle number 36, but in reality, I have the information that I need. Let me worry about the fraction first, and then I'll deal with the square root. I know cosine of theta is 4 over 5. So I have 1 minus 4 over 5. So I'm dealing with the fraction only. I'll deal with the square root later. I have 1 minus 4 over 5 over 1 plus 4 over 5. Looking on the top, my 1, let me write that as 5 over 5. So that gives me 1 over 5. Looking at the bottom, let me write that my 1, let me write that as 5 over 5, just to have a fraction with the common denominator. So that gives me 9 over 5. So I have 1 over 5 times 5 over 9. Remember, I have to do the reciprocal of the second fraction. My 5s become 1, so they cancel out, they become 1. So I have 1 over 9. Now let me worry about the square root. I'm squaring everything. The square root of 1 is 1. The square root of 9 is 3. There you go. The tangent in the first quadrant is positive. So I'm just looking at the 1/3. Okay, so for 34, 35, 36, I just said, oh, tangent is positive or tangent is positive. Now on the formulas, I have a plus or minus, and it said depending on the context. Tangent is sine over cosine. Looking at 34, I'm just going to look at the signs. Sine of theta and cosine of theta. Sine of theta is a positive, right? Because I have 3 over 5. Positive 3 over 5. Cosine is also positive. Positive divided by positive gives me positive. That's how I knew that was positive. Now looking at number 35. The sine, here it is negative. The cosine is negative. Or better yet, how can we do this? First quadrant. Let me go back to the unit circle that we used before. Remember, tangent, I said, is sine divided by cosine. Just looking at the signs. Positive divided by positive. Tangent in the first quadrant is positive. Tangent on the second quadrant is negative. Tangent on the third quadrant is positive. And tangent on the third, here it is negative. Okay. So that's how you guys are going to know. Remember, tangent of the first and third quadrant are positives. Tangent of the second and fourth quadrant are negatives. That's what I came in and said. The formulas that I gave you guys had a plus or minus depending on the context.